Okay, I'm talking about the Algebra 2 Semester 1 exam topics in Chapter 1. We're going to be graphing quadratics, solving ax squared plus bx plus c equals 0. Usually that involves factoring. Operations with complex numbers, that's a plus bi. Completing the square, which we can use to help us solve quadratics. And then obviously the quadratic formula that'll solve any quadratic. So if you're only choosing one to learn, which I don't recommend, the quadratic formula solves more than most. In Chapter 2, we have properties of exponents. Okay, as I was saying, in Chapter 2, properties of exponents, power to a power, you multiply exponents, multiplying like bases, you add exponents, dividing like bases, you subtract exponents, things like that. Add, subtract, multiply, divide polynomials, factor, solve polynomial equations, which basically is how you find zeros. Zeros are solution or roots. In Chapter 3, you're finding the nth roots. Sometimes they are square roots, third roots, or fourth roots. Sometimes even the fifth root of 32. If I gave you something like the fifth root of 32, that is because 2 to the fifth is 32. The fifth root of 32, I believe, is 2. But fifth roots are kind of rare. Properties of rational exponents. That would be like 8 to the 2/3. It's always power over root. Do the root first. Always try to do the root first. It makes the number smaller. Third root of 8 is 2 to the second, would give me 4. How about function operations and composite functions? F of g of x, things like that. Inverse functions. If you do composite f of g of x and you end up with simply x, that means they're inverse functions. And the last thing we did this semester was solving rational equations, that is, equations that have radicals in them. Now we're going to do some specific questions. Okay, we're going to start some problems from Chapter 1, such as graphing these parabolas, basically. I know the vertex occurs at x equals negative b over 2a. Your b is negative 8. So I have negative of a negative 8 over 2 times a, which is 1. That's 8 over 2, makes x equal 4. 1, 2, 3, 4. That's where the vertex will occur. Negative b over 2a. Now if I put a 4 in, 4 squared is 16. 8 times 4 is 32. So this gives me negative 16 minus 20, which is negative 36. You may notice that I didn't increment my y-axis because sometimes the numbers are very big and very small. Because a is positive, that means this parabola is going to open upward. I know if I put in a 0, I'm going to go through negative 20. So I know it's 0, negative 20. And then it comes down to this vertex, which is a minimum, and comes back up. Now, if you're really good, you'll notice that this is 4 over. Go another 4 over, and that would be at 8, negative 20. So now I have a vertex and 2 symmetric points. This right here is also called the axis of symmetry, x equals negative b over 2a. These could also be completed on a graphing calculator, assuming you have one and know how to use yours. If you're going to get a graphing calculator, please make sure you get one approved by the College Board. Otherwise, you won't be able to use it on advanced placement tests, nor the SAT, which are kind of important. This second one is in vertex form. The vertex is at h comma k. So to me, it looks like negative 3 comma 5 is my vertex. So I'm going to go to negative 3, and again up here somewhere around 5. I didn't increment my y-axis, but I am labeling my points. And because a is negative, I know that this parabola is going to open downward. So it's going to come up to the maximum there and then downward. Now I do know, well, actually, I don't even ask for extra symmetric points. Your axis of symmetry is x equals -3, which is the x-coordinate, x value of your vertex. Now on these, we want to factor. I'm looking for factors of 30 that add to -11. If I do a times c, 1 times 30 is 30, and b is -11. They have to multiply to give me 30 and add to -11, such as -6 and -5. They multiply to 30 and add to -11. So to get x squared, you have to have x times x. Most times you have trinomials will factor into the product of two binomials. Because a is 1, I can put these numbers right in. And now I have it in factored form. This second one is in, or number 4 here, is in a difference of squares. You have a squared minus b squared. That's going to factor into a plus b, a minus b. So the square root of x squared is x. 1 is plus, 1 is minus, and the square root of 64 is 8. So I factored number 4 using the difference of squares. In number 5, you have a times c. That's 2 times -15, giving me -30. b is 7. It has to multiply to -30 and add to 7. With practice, you'll get good with the numbers. I believe 10 times -3 is -30, and 10 plus -3 is 7. Now to get 2x squared, it has to be 2x times x. Now I connect my outsides and I connect my insides. This number 2 goes into the 10, so I put it up there and the -3 here. 2 times what is 10? 2 times what is 10? Well, that would be 2 times 5, I believe, is 10. Now we're going to do 1 times what is -3? 1 times what is -3? Well, that would be a -3. So now you should have it factored into 2x minus 3 and x plus 5. I always check, does last times last equal last? Does -3 times -5 equal -15, which it does. On number 6, we want to use the skills of factoring to be able to solve the polynomial, or the equation. So I'm going to factor this the same way. The only thing is it equals 0. X times x equals x squared. I need factors of -40 that add to -3. So that might be -8 times 5. They multiply to -40 and add to -3. So I put them in because a is a 1, -8, and +5. At this point, I make each of these equal 0 because it's called the zero product theorem. If something times something equals 0, one of the two factors must equal 0. If x minus 8 equals 0, the solution would be x equals 8. If x plus 5 equals 0, the solution would be -5. So these are my answers for number 6. In 7, we want to isolate the variables. So the opposite of multiplying by 2 would be to divide by 2. So that isolates it into a minus 7 quantity squared equals 8. I'll write it down one more time because I know to get rid of the square I have to take the square root. If I do it to one side, I have to do it to both sides. The square and the square root eliminate each other. 8 could be called 4 times 2 or 2 radical 2 if you're taking the square root of it. If you take a square root in an equation, please don't forget to put plus or minus. Now to solve it, you just add 7 because you're trying to get a by itself. So your answer would be 7 plus or minus 2 square roots of 2. Okay, continuing, these are complex numbers. Complex numbers are always in the form of a plus bi. Anyway, this is just subtraction, so what I would do is just distribute this negative. So that makes a negative 4 and a positive 5i. Combining like terms, 3 and negative 4 combine to give me negative 1. Whereas negative 2i and positive 5i combine to give me a positive 3i. Please note that I wrote my answer in the form of a, which is a real number, plus or minus bi. That's called standard form for a complex number. Now, to do imaginaries or complex numbers, it helps to know your powers of I. So I'm going to write them down if you're interested. I is the square root of negative 1. I squared is negative 1. I to the third would give me negative I, and I to the fourth is a positive 1. After that, they start repeating, but it is handy to know these values. So I'm going to distribute. 3 times 4 is 12. 3 times negative I is negative 3i. 2i times 4 is 8i, and 2i times negative I is negative 2i squared. So I should be able to combine these both and give me a positive 5i. But what is I squared? Well, I squared is negative 1. So that really means plus 2. So 12 plus 2 is 14. And you have your plus 5i. Again, in a plus bi form. Number 10 is a little harder because you're not allowed to leave radicals in the denominator. I's are radicals. So to get rid of the I in the denominator, you're going to rationalize it. To rationalize it, you need the conjugate. In this case, a complex conjugate. The conjugate of 2 minus 3i would be 2 plus 3i. All you do is you change the sign in the middle. On top, we're going to distribute. 3 times 2 is 6. 3 times 3i is 9i. And then I times 2 is 2i. And I times 3i is 3i squared. Well, 3i squared, because I squared is negative 1, that's going to become a negative 3. 6 and a negative 3 is 3. And then 9i plus 2i is 11i. Now on the bottom, you could distribute it, or maybe you could learn the rules. A minus bi times a plus bi gives you a squared plus b squared. So I know that this is 2 squared plus 3 squared. That would be 4 plus 9, which I think is 13. The proper way to write this is a plus bi as such. Okay, we did up to 10. Let's look at 11. We want to solve by completing the square. To complete the square, I usually will move the constant to the other side. So I have 4x squared plus 8x, and I'm going to move the 3 to the other side. You may notice I left a strategic space here. That's for completing the square. Now you can only complete the square if your leading coefficient is a 1. Right here it's a 4. So I resolve that by factoring out a 4. I'm fully aware that I could factor out a 4x, but I don't want to factor out a 4x. I just want to factor out a 4. So once I factor out the 4, verify that it's still 4x squared plus 8x, and it is equivalent. Now we're going to complete the square, which means you're going to turn this into a perfect square. The square root of x squared is x, and you're going to turn it into a perfect square. This is called completing the square. Half the middle, half of 2 is 1, that goes there. Square that number, 1 squared is 1, that goes here. You really added 4 times 1, which is 4. So if you added 4 on one side, you have to add 4 on the other side to keep it balanced. Now you could divide by 4 to get rid of the 4 in front. That would give me x plus 1 quantity squared equals 1/4. I divided by 4. To get rid of the square, you might take the square root. The square and the square root eliminate each other. Don't forget plus or minus, square root of the top, square root of the bottom. And now I subtract 1. So I get -1 plus or minus 1/2. What is -1 plus 1/2? That would be a -1/2. What about your other one? What's -1 minus 1/2? Well, that would be -1 1/2. So I believe we have a couple of results here. Now, the quadratic formula in 12. You need to know the quadratic formula, and you need to know that this is ax squared plus bx plus c equals 0. If so, you're going to fill into x equals -b plus or minus square root of b squared minus 4ac, the entire thing divided by 2a. So let's fill into this. Negative plus or minus squared 4 something something 2 something. So let's fill it in. What is b? B is 10, so I put the 10 in. What is A? 3. I think the A is on bottom also. And what's C? -5. So you get -10 plus or minus the square root of 100 plus, because two negatives make it plus. Let's see, 3 times 4 is 12, times 5 is 60, so you get the square root of 160. So you have -10 plus or minus radical 160 all over 6. Now 160 under a radical could be square root, could be broken up into 4 radical 10, I believe. So -10 plus or minus 4 radical 10, and they're all divided by 6, I think. These are all divisible by 2, so I could do half of 10, half of 4, and half of 6. And that's how I would solve one using the quadratic formula. Okay, on to 13. We want to apply the properties of exponents. Power to a power, you multiply. So the power of 1 times 2 is 2. I think this multiplies to give you -4 and y to the 6. 3 to the second is 9, y to the 6. Do you see a negative exponent? That just goes to the other side of the fraction and becomes a positive exponent. So this would simplify to something along these lines. Number 14, we want to multiply. So 3x times 2x squared is 6x to the third. 3x times 5x is 15x squared. 3x times -1 is -3x. -2 times 2x squared is -4x squared. Please notice I'm lining x squareds up with x squareds. -2 times 5x is -10x. Again, I'm lining the x's up with the x's. And -2 times -1 is a +2. Now we just need to combine like terms. 6x to the third plus 11x to the second minus 13x plus 2 should be your answer. Okay, that was just distributing. If all you know is FOIL, you can't do a binomial times a trinomial. I'd much rather you learn it as distribution than FOIL. Number 15 is division. We could do long or we could do synthetic. I'm going to try to do both. 2x squared minus 5x plus 7 is divided by x minus 3. X times what is 2x squared? X times what is 2x squared? Well, that would be 2x. 2x times x is 2x squared, but what's 2x times negative 3? Negative 6x. In division, you change your signs and add. So those go away. That becomes a positive x plus 7. Now again, x times what is x? Well, x times 1 is x. 1 times x is x. 1 times negative 3 is negative 3. Again, change your signs and add. I believe your remainder is 10. So what you do is you put plus your remainder over your divisor. So the answer should be 2x plus 1 plus 10 over x minus 3. If I wanted to do this synthetic division, I'd have to make sure that all of my powers are represented in decreasing order. That would be x to the 2, x to the 1, x to the 0. They're all there in order. Bring the coefficients down, 2, negative 5, and 7. Leave a space, draw a line, make a box. The number that goes in the box is whatever makes this part 0. So what makes that 0 would be 3. The process is you bring the first number down, so you get a 2. Then multiply. 3 times 2 is 6. You put it here and add 1. Then multiply. 3 times 1 is 3. Put it here and add. So this means 2x to the 1 less power, so it would be 2x to the first, plus 1, plus your remainder over your divisor. So hopefully I got the same answer doing it long division or synthetic division. 16, we want to factor. To factor difference or sum of cubes, you need to know the sum or difference of cubes formula. This is a cubed minus b cubed. It's going to factor into a minus b, a squared plus ab plus b squared. So I need to write these as something cubed. What cubed is 8? Well, that would be 2. And what cubed is x cubed? X. What cubed is 27? Is 3. So I'm going to take this formula and realize that the a is 2x and the b is 3. So if I have a minus b, it would be 2x minus 3. A squared, if a is 2x, you square it, you get 4x squared. Plus is part of the formula, a times b, that's 2x times 3, which is 6x. Plus, again, is part of the formula, b squared. If b is 3, b squared is 9. And you should have that factored. Okay, number 17, we want to factor this. I see this as 4 terms with no common factors. Sometimes the best way to handle these are to split it. Excuse me. Out of the first 2, I'm going to factor out an x squared. That would leave me with x minus 3. Out of these, I'm going to factor out a negative 4. That again would leave me with x minus 3. This is still negative 4x plus 12 if you looked at it through distribution. Both of these contain an x minus 3, so I'm going to factor it out. If I took those out, what remains would be x squared minus 4. That is the difference of squares, and x squared minus 4 might factor into x plus 2 times x minus 2. Now we have that completely factored. Okay, after 17, we're moving to 18. We want to find zeros. Again, we want to find zeros. Usually one of the zeros is a factor of this last constant. So, factors of positive, negative, 40, 20, 10, 4, 8, 5, 2, and of course 1. I always try the smaller ones. All powers are represented in decreasing order, so I'm going to try synthetic division until I get a remainder of 0. So, the first number I'm going to try is 1. Bring this down, multiply. 1 times 1 is 1. Add. Multiply is 2. When you add these, you get negative 20. Multiply is negative 20. That does not give me a remainder of 0. So, 1 did not work. I'm going to move to negative 1, 2, and negative 2. But anyway, we'll try negative 1 now. Bring the 1 down. Multiply is negative 1. Add is 0. Multiply is 0. Add is negative 22. Multiply is 22. And that is not 0 either. So I can rule out 1 and negative 1. Now I'm going to try 2. Bring the 1 down. Multiply is 2. Add is 3. 2 times 3 is 6. When I add is negative 16. Multiply, I think, is negative 32. That does not add to 0 either. So I would go ahead and try the next number in line, which is negative 2. Bring down the 1, multiply is negative 2. Add is negative 1. Multiply is positive 2. Add is negative 20. Multiply is positive 40. And I think I just found one that gave me a remainder of 0. So what does x, that negative 2 means that 2 makes it 0, makes it x plus 2. This is x squared minus 1x minus 20. These are all the numbers from my division. Now, how does this factor? Factors of negative 20 that add to negative 1 would be negative 5 to positive 4. Making each of these equal 0 should give me solutions of negative 2, positive 5, and negative 4. You'll notice the maximum number of solutions, or 0, should correspond to the degree of the polynomial. So I have 3 solutions on 18. 19, we're doing power over root when you have fractional exponents. Again, I recommend you always do the root first. So it's a 5th root of 32 raised to the 1st. 5th root of 32, I think I may have already told you, 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 a 5th time is 32. How about this one? This is power over root. So you got to do the root, square root of 16, raised to the negative 3 power. Square root of 16 is 4, raised to the negative 3 power. If you have a negative exponent, it goes to the other side of the fraction and becomes positive. And I think 4 to the 3rd is 4 times 4, which is 16, times 4 again, which is 64. Third roots are a little different. Third roots of, you have to look for things like third roots of 8, third roots of 27, because the third root of 8 is 2 and the third root of 27 is 3. But they get pretty big pretty fast. 88 could be called 8 times 11. So the third root of 8 is 2 times the third root of 11. That's all you could do on 21 to simplify it. 64, we want the third root of 64 times the third root. 4 is bigger than 3, so I might make it x to the third times x to the first. And 2 is smaller than 3, so I'll probably leave that in. Third root of 64 is 4. The third root of x to the third is x. These you can't take any further out because the power is less than the root. So you have to leave them under the root. So it would be the third root of x, y squared. And that should be 22 simplified. Okay, after 22, we're going to try these composite functions. F of g of 2. First thing is, you might wish to find g of 2. So, g of 2 should be 6 minus 1 or 5. So this g of 2 here is a 5. Now I need f of 5. How do you find f of 5? Well, you replace in every x with 5. So putting in a 5, 5 squared is 25 times 2 is 50, minus 15 I think is 35. So this result should be 35. Again, I found g of 2 first. G of 2, I put 2 in and I got a 5. Then I know that was g of 2 is 5. Now I need f of 5. So I put 5 into the f function and got 35. Okay, now I'd like to do f of g of x. f of g of x, I look at this is called a composite function. You want to do f first. F's on the outside. The f function is 2x squared minus 3x. And then you want to replace the variable with the other expression. So I want to replace the variable with 3x minus 1. When I work on this now, I get 2, I square the first, twice the product, square the last, distribute this negative 3 is negative 9x plus 3. Distributing this 2 is 18x squared minus 12x plus 2. Then you still have minus 9x plus 3. So what do I end up with? 18x squared, what's negative 12x and negative 9x? I think it's negative 21x. 2 and 3 combine to give me 5. And that's what f of g of x should equal for 24. Okay, moving on, we want to find inverse. Right now it says y equals 3x minus 2. When I want to find an inverse, all I do is I switch x and y and solve for y. So I switched x and y, I drew a line to show they're not equivalent anymore. Now I'm going to solve for y. So I would have to add 2 and divide by 3. So you might call it that, or you might call it 1/3 x plus 2/3. Now the inverse of f of x is written like this, f with a negative 1. So I would write my answer probably like this, x plus 2, the whole thing over 3, but calling it f negative 1 of x or f inverse of x. Now I would have to restrict this. Right now it's a parabola opening up. Horizontal line means it's not 1-to-1 and has no inverse. I don't plan on trying to trick you on that. But I think if I said x is greater than or equal to 0, you would not have this whole parabola. I think you'd only have half of the parabola. Then it'd be 1-to-1. Anyway, let's find the inverse. Right now it says this. I need to switch x and y and solve for y. So the y becomes an x and the x becomes a y. If I subtract 4, I get this. How do I get rid of a square? You take the square root. So it should be the square root of x minus 4. And again, I'm going to write f inverse equals radical x minus 4. So that's how I would find inverse functions. Switch x and y, solve for y. Now solving radical equations, you want to isolate the radical. You want to get the square root or cube root or whatever all alone on one side of the equal sign, which this one is. To get rid of a square root, you square. What I do to one side, I have to do to both sides. The square and the square root eliminate each other. 11 squared is 121. If you haven't learned how to multiply two-digit numbers times 11, a man named Trachtenberg figured this out in World War II prisoner of war camp or concentration camp, and he discovered that if you took two-digit numbers times 11, you could simply split the digits, 1 and 3, add the digits in the middle, and you'd get 143. So 11 squared is 11 times 11. Split the digits, add the digits. 1 plus 1 is 2. So 11 squared is 121 if you didn't know that. I always try to credit Mr. Trachtenberg with that method. Add 1 to isolate the variable. That gives me 2x equals 122, I believe. Opposite of multiplying 2 is to divide by 2, and we get x equals 61. Let's plug it in and check. 2 times 61. 2 times 61 is 122. Minus 1 is radical 121, and yes, that does equal 11. So I know that this value does work. You definitely need to check your answers on radical equations. On this one here, 28, I have this. I already have the radical isolated, so I need to get rid of it by squaring it. If I square one side, I square both sides. You could write this out and FOIL it or distribute it, but I'd rather you learn the pattern so it's faster. Square the first, square the last. 3 squared is 9. Multiply these and double it. So negative 3x doubled is negative 6x. When you square the square root, it goes away. Subtract x makes this negative 7x. Add 1, I think, makes that 10. Now I have it equal 0. The only way that I know how to solve quadratics is to make it equal 0, which I've done. Now, are there factors of 10 that add to negative 7? Sure, negative 5 and negative 2. So what makes this 0 is 5. What makes this one 0 is 2. I do not think the 2 will work because if I put the 2 in, if I was to put the 2 in up here, what's 2 minus 3? A negative, and a square root can never equal a negative. If you put the 2 in over here, you get negative 1 equals 1, and that doesn't work. If you put 5 in, what's 5 minus 3? And what's 5 minus 1? Well, 5 minus 3 is 2. That's radical 4. 2 does equal 2. So the only solution to this one is the answer of 5. Anyway, I hope this helps for your exam review. Good luck.